So now we're going to write a search engine, do some of the things. We're going to do PageRank and we're going to visualize it in a web browser and show the weights. We're really only going to do PageRank on one page because you want to have links that more than one page that points to a page so that you can figure out which pages are more or less important. And then we'll visualize it. We'll run the PageRank algorithm and we'll separately do all this. So at this point we're going to do pretty much the web crawling, the index building, and the searching. We're not going to really search it. We're going to visualize the index, but you could write a simple program to do searches for keywords and figure out which page was the most likely page for a keyword. And that would be a fun additional thing to do. So the web crawler is this program that hits a page, pulls down the HTML, parses the page, looks for links, makes a queue of incoming links that are as yet unretrieved, and I'm going to do this in a simple SQLite database, and starts out with, the database basically starts with one link as the starting point, and then it retrieves that page, and then you see the database end up with lots of unretrieved pages, and then it goes back in and picks a random page and retrieves that one, and then it just expands and expands. This code that I've built that you're going to play with only stays on one website, otherwise it would go crazy. But of course Google doesn't use an SQLite database running on your hard drive. But you'll get the idea. You'll see this thing exponentially gain links, and you'll run it for a while, pull down 1,000 web pages or whatever. But of course, make sure that you don't violate any terms and conditions. And again, I've got some data sources that you can use, and they're not rate limited, but you can also use things like Wikipedia, which I think they sort of discourage you, or drchuck.com, which has no rate limit, or who knows what, right? So just be careful. Don't do this on Facebook, and don't do it on Google. Don't get yourself in trouble. And if you're using, you know, a internet connection where you're paying for bandwidth, be careful. So this is the idea of the web crawler, and this isn't my picture. This is the classic picture of a web crawler. Read a page, parse it, take all the URLs and stick them in a queue, grab again and again. So for us, the scheduler is going to do it as long as you'd say, oh, do 100 pages, or it runs until it blows up. I mean, and again, these processes that have the network in the loop, it's really important that they behave well when they blow up. And that's why databases are so useful, because you can be writing along to the database and some random thing happens and blows your data up and you start over. So you're reading these things, you're storing each page, building up your storage, etc., etc. So you just keep on doing that. And with this program, you'll be able to retrieve some stuff, then run the PageRank, then you can retrieve them more, and then you can run some more PageRank, and you can kind of see how Google sort of evolves its index over time. Of course, we're so much simpler. And like I said, be careful when you crawl. You're going to run a crawler that just goes as fast as it can, but Google doesn't do that. It's careful not to overwhelm any websites. It's trying to be smart about the use of your bandwidth on your website. There is a file. Our code won't bother looking at this. But there's a file called robots.txt that real web crawlers look at, and it gives a list of the things you are allowed to look at and not allowed to look at. And so if you go to Google and you see a search that says, we are not allowed to show you the summary text of this page because of the robots.txt, it's there, and you can go and you can actually see a robots.txt. Like on, just go to any website, it's at the top root, blah, 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 /robots.txt. It's not a path. It's not /this, /that, /something else robots. It's at the very, very top of a website. The index building uses the PageRank algorithm. And the whole goal of the PageRank algorithm is to figure out which pages have the best links. So having the most links is really easy. You can just say how many links go to this. But the problem is you got to figure out the value of those links. And then you have to, how do you figure the value of those links? By looking at how many good links come to it. So it turns out that it's an infinite problem. It's an infinitely difficult problem to use PageRank. But you can approximate it, and what happens is after a while it converges to a reasonable value. And so we're going to run the search index, and each time it runs, you're going to see that it says, you know, how much did these numbers change? And what happens is, in the beginning, they change very wildly, but quickly they flatten out. And it has the best way to think about the PageRank is think about how water runs, where you have a small little stream going by a house, and sometimes it rains, sometimes it's dry, and sometimes, you know, and there's like a little lake, and the stream is always running, and it doesn't go up and it doesn't go down. It might go up a little bit if it rains a lot, but in general there's sort of a steady state, meaning that whatever water's coming in is about the same as the water going out. So we think about this in terms of web pages. The value of the links coming in is roughly the same as the value of links going out. So when that starts to balance the in and the out value from each of the nodes, then you've got pretty stable. And so what Google does is they have a really relatively stable assessment of goodness and value of pages, and they use that to compute PageRank, and then they throw a few more pages in, and it kind of has to adjust for a while, but it reconverges. And so this is a calculation that generally converges, and it doesn't vary wildly. And that's why Google's pretty good at kind of arriving at the true value of something. So let's take a look at what we're going to do in this application. Again, we have a file that is going to spider the web, and we only have one database. Again, in this one, we'll have two databases in the next one. And so this is spider is the restartable part. And what we actually do is we put one URL in, the starting URL, and then spider walks in and asks, are there any unretrieved pages? And it does that randomly. It sort of picks among the unretrieved pages and says, okay, great, I'll go retrieve that page. And then I'll parse that page, and then I'll put in a bunch of new unretrieved pages, okay, as well as the text of that page, and then a bunch of unretrieved pages. And then it'll go back up and it'll say, oh, give me one of the randomly non-retrieved pages, and it'll grab a next page and pull that page down and then add to it. And so this is like, there's a page and then a to-do list. And then this one becomes a page and then adds a few more things to the to-do list. And so the to-do list, or the unretrieved URLs, grows very rapidly. And the retrieved ones grow sort of as you retrieve them one at a time. But you've always got this long list. If you have a really short site that only has like 2 links, if you start at drchuck.com/page1.htm, it'll go to page 2 and then go back to page 1 and it'll be out of things. It'll have retrieved all of the pages. And so if you have a website that has no external links or has very few pages and they point to each other, this will run out of things to do. But if you go to a page like my blog or the code that the sample stuff that I have up for you to spider for testing on drchuck.net, it'll run for a very long time, and you'll have far more pages to retrieve than pages that you retrieve. But that's okay. At some point you can stop this. Maybe it stops because you ran out of bandwidth, or maybe your computer went down, or who knows what, right? But it's okay. This is a restartable process because it always has some pages that are retrieved and some unretrieved pages. You start it back up, it picks randomly from the unretrieved pages. Your database is the sort of persistent state of your spider rather than a bunch of dictionaries or lists inside the Python, which go away when the program dies. And so at some point you have, let's just say, a few hundred pages in here and a few thousand unretrieved pages. You can run the PageRank algorithm. And what the PageRank algorithm does is it loops through all the pages and figure out which pages are linked to which pages, and then reads the numbers and then updates the numbers, and then does that some number of times. And so this is where the numbers, all the pages sort of start out with goodness of 1. I think this printout is showing that goodness of 1, and then it changes, and then the goodness goes to some of the goodness goes up to 2, some of the goes to 7, and whatever. But then it does this over and over, and then it uses these numbers, and then they change again. And so there's a number of time steps that this PageRank runs, and you will see as the PageRank runs, when I show you the code, you'll see the average sort of change in these numbers across all these things, and you'll see that the average goes down very rapidly as you get through. And so usually with a few hundred or even thousand pages, like 100 plus times running this algorithm, and these numbers have converged. And that's when you sort of can begin to trust the numbers. Now there's this one program called SP Reset, which sets all the pages back to 1, so you can start this over. So if you were to spider for a while, run SP Rank for a while, play around, and then you wanted to spider some more and start it over, you could say, oh, let's start the PageRank completely over. Or you could simply take the new pages and watch it adapt. Either way, this is just a way to reset all the pages to have sort of their initial value of a goodness of 1.0. So at some point you run this. This part here runs really slow. This part runs super fast, like in the blink of an eye. This one is pretty fast. And then at some point, you've got these pages that have, numbers on them. They have values on the pages. And there's a couple of programs that allow us to visualize that. One is the dump, which just reads it and checks to see. It shows the new page rank, the old page rank, and various other things, and shows just a way to dump it. And then there's this thing that reads the whole thing. You say, I'd like to do 25 of the top, the best. It sorts it by page rank, and then produces a JavaScript file that has just the numbers in it. And then there is some HTML and a visualization library called d3.js, which you can read about, that when the HTML starts, it reads this and has this nice force-directed layout of the page rank. And you can hover over things and you can see what page rank you've got. And so that is the PageRank algorithm that we're going to do. And up next we'll do the largest and most complex of these things, and that is the email. We're going to spider some email, which is about 1 gigabyte of data. Okay?